Hello everyone, today we'll talk about the problem single number 3. We're given an integer array, and in that array exactly two elements appear exactly once and all the other elements appear exactly twice. We have to find those two elements that appear exactly once. However, we have to do that in linear time complexity and constant extra space. This problem is a variant of a simpler problem where all the elements appear twice and exactly one element appears once. And the solution to that problem, which is essentially a prerequisite and will be used in this solution, is to notice that, as we know, when we XOR two numbers together, so for instance if we XOR A XOR B, and then we XOR B again, then we're left with A again. So essentially whenever we XOR a value with something twice, it's as if we didn't XOR it with that value at all. And so, if there was exactly one number that appeared once and all the other numbers appeared twice, then if we just got an XOR of the whole array, then that will be the missing value. So that will be the solution to the simpler problem. And if we tried to do that in our problem, what we would get here would be the XOR of the two missing elements. So if those two missing elements are x and y, we can calculate the XOR of x with y. So now our problem becomes how to transform this XOR of x and y into those separate values, x and y. And probably the simplest and most clever way to do this is to notice that, of course, this XOR of x and y is not equal to 0. So it has some set bit. And what does this set bit tell us? Well, it tells us that at this position, those two numbers differ. So exactly one of them has a 1 at that position and another has a 0. Well, this is quite obvious. Two numbers differ if they differ at least one position. But now, if you look at any position where they differ, so we just select any position where they differ, and we imagine splitting the original array that we've got in our problem into those with a 1 there and those with a 0 there, then one of our numbers will be in the first array, in the ones array, and the second number will be in the zeros array. And all the numbers in the original array, all the pairs of numbers that are the same, will either both be in the first array or both be in the second array. But now, what we can notice is that this problem, in both these cases, is just one missing value. So we have reduced our problem to the classic problem, and of course we just solve it by XORing what remains. And so one way to implement it, I will be using the function reduce, where reduce function list works like so. It goes through the list. It maintains an accumulator whenever it sees a new element. It changes the accumulator to the result of accumulator XOR, the new element that we update with. So this is just the function with two arguments that we provide. So this would be a way to calculate the XOR of the whole array. So now we have this full XOR, which is x XOR y. And now we have to find a bit that is set in that x XOR y. We know that it is not 0, so one set bit exists. One way to do that is just to start from the least significant bit and multiply it by 2, so shift it to the left, until the bitwise end of the full XOR and that bit becomes something, because that means that this full XOR has that bit set. And now we can finally use our trick with splitting this array based on this one bit. So all the values that have this bit set will go to one of the arrays. Those that do not have this bit set will go to the other array. And then we have two instances of our original problem. So we will reduce our array twice. First by taking all the values, or rather maybe replacing all the values that do not have that bit set with 0. and the second time with replacing all the other values with zeros, and leaving only those that do not have this bit set. And as we said previously, since this is just the solution to the simpler problem, this just gives the missing number. So this is the missing number in the first array, this is the missing number in the second array. By missing, of course, I mean the one that appears exactly once. And those two are different, and those are our result. So this is quite a tricky problem, utilizing another problem that if you don't know the solution to, you might be really stuck. But even if you know the simpler solution, I think it's still quite a leap to come up with this idea. But it is a really nice, clever idea. So I hope that you enjoyed solving this problem.